So there are a whole class of engines called hit and miss engines. They were incredibly popular from about the 1880s to the 1930s, even the 1950s. They were a sort of halfway house between a steam engine and an internal combustion engine, and what they were was a great big flywheel. So if you give a flywheel a mighty shove, of course it will continue to spin under its own inertia, and hit and miss engines were basically that. The piston had an injection of fuel, a spark, it would bang, give off a mighty kick to the flywheel had a belt attached to it, and you could run new machinery. Of course, as the flywheel started to run down, there was a governor attached that would close a latch, more fuel, more spark, another kick. And they had a characteristic kind of chuffing, whooshing sound to them as they ran. Now, the main reason you don't see such a lot of them around is because a lot of them were given up to the steel drive during the Second World War to make tanks, planes, boats, but they were a very reliable machine that just chugged on for ages because of their inherent simplicity. They were open to the atmosphere, so they needed a fair bit of maintenance, but they were incredibly reliable, incredibly simple, and did a job making them very popular. Now, another way of referring to this class of engine is flywheel engine. Is all you really need at the heart of it was that flywheel with a kick that was a mechanical battery used to run something via a belt. And of course, this idea hasn't actually died, it's still with us, and perhaps one of the most interesting iterations of this is a set of electric motors being run as these flywheel engines, or if you like, hit and miss engines. Now, there's a chap who does this called Lid Motor. He's got his own YouTube channel, he's been doing it for years, and basically what that guy doesn't know about pulse engines isn't worth knowing. What you do is have a flywheel with some magnets attached. As the magnets pass usually a reed switch, it operates a battery, gives it a coil of pulse, and that of course gives the flywheel a kick in exactly the same way as hit and miss engines. Now, it turns out you don't actually need the reed switch. You can wind a second coil that as the magnet passes, it gives it a pulse. That operates a transistor which turns on a battery and gives the main drive coil a pulse, and off goes the flywheel. Now, we could make that a couple of coils, a transistor, a capacitor and a resistor, and you're away. You'll have it actually made. But I came across this. It's a clock pendulum mechanism available on Amazon, and I bought two of them for £10. If we look under that cover, what we get is this. It's a little circuit. You'll notice that there's a coil on that circuit and a tiny integrated circuit right there. That little chip combines a transistor, a capacitor and a resistor all in one little IC, and it's able to pull from that pulse coil to turn it off and on, and a battery fits in there to make a pulse motor. So the whole thing is in one neat little bundled package. And you know, sometimes if the grapes are more expensive than the wine, buy the wine. I'd have a lot of trouble being able to wind that hair-thin coil. We're going to get a good voltage because there's so many turns and it's so thin. And of course there's all this soldering to do, and then the parts themselves. So finding that was quite a thing, really. Big Clive has done a breakdown of what exactly this circuit is, but we can use this circuit directly to make ourselves a pulse motor, and that's what I thought I'd do. I thought I'd design, print and build a pulse motor all in an afternoon. In a lazy Sunday afternoon when it's sunny outside and I feel like doing something, I'm going to 3D print a pulse motor and use this to actually run it. So, let's get on with that. So the first thing I did was draw this up in Tinkercad, and it's a pretty simple machine without many components. This red and blue here are the stand, these three parts, the blue wheel, the pink wheel and the cream centre make up the flywheel, and that's the axle. Now if you look at the axle, you'll notice there's a little hole in there because you're going to need some extra parts. One thing you're going to need is a needle that goes in that little hole, and the next thing you're going to need are some magnets that fit in these square spaces. So the magnets you need are 1 centimetre by 1 centimetre by 2 millimetres. Anyway, let's get that printed off. To make this nice and quick and easy, we're going to reuse the case. So we pop that back in there, pop the top back on, And then what we want to do is snip it here and here, and it will extract that whole unit as one piece. And there it is, back together and snipped off. So I've just snipped off the body, put a battery in it, replaced everything, and we've got this one whole drive unit that we can just basically glue onto our model. Now when you buy magnets, especially flat ones like this, what you find is they're normally magnetised with one surface north and the other surface south. I checked out the pendulum. What I found was that this was north and this was south. So it's not north-south that way, it's north-south that way. And so I figured we'd be better off replicating what the pendulum magnet was done so that it fitted with the drive. To do that, I used these. These are tiny actually. They're 1 centimetre by 0.5 centimetre by 1 millimetre. And if I fold them in half like that, what I automatically get is a north side and a south side, and stuff those into the flywheel. 2 layers deep, that's what you get. We've got a north, south, and they're replicating the pendulum magnet. To finish the flywheel, the ring goes on that centre piece, then that piece drops on top of there like that, and that's the flywheel finished. To finish the base plate, glue this bit at 90 degrees on that bit, and you'll see there I've got the trimming knife blade, which is just a bit of steel for the bearing to rest on, and of course we've got our 2 skater bearings, one goes in there, and one goes in there. To finish the axle, get a household needle and stick it in that hole. Finish the assembly, slide the flywheel in there and drop the axle down through the centre. With the needle resting on the metal plate, what you should find is that that is incredibly easy to spin. Now we take our pre-prepared drive mechanism and attach it onto there. All of this, incidentally, is held together with super glue, because that's a really good bond for this kind of thing, and then that model is ready to go. And there it is, chugging away. Now it's going at a pretty fixed speed, because remember this is a pendulum drive. As I said before, you can construct this yourself, and if you construct it yourself, then you can change that speed. Here you're fixed with what you've got, but it is a project you can do in an afternoon right from ground zero. Now I used the battery, but I could of course use a supercapacitor. If you use a supercapacitor, it becomes much more impressive in what it can actually do and how long it can actually run. Lid Motors had one of these running, I think it's for something like 6 years. So there you go, a hit and miss, a pulse engine, a flywheel motor, pulse motor, whatever you want to call it. And there's a project to do that I really did design, print and build in less than a day, probably about half a day on a Sunday afternoon, so can be a fun project. Now there's lots of actual work that goes on these things, looking particularly actually at the electronics that drives it and trying to get the least amount of energy used to keep that thing turning, but it also makes a pretty interesting desk toy. I will put the files on Thingiverse if you're interested. Thank you very much for watching, and I do hope you enjoyed the video.